Hey everybody, this is Miss Moriarty, and I'm here to discuss with us topic 7.5, which is all about indoor air pollutants. Now, we talked a little bit about indoor air pollutants today with our scavenger hunt, but the main, goals of this topic is to understand that when we evaluate indoor air quality, we need to do that because we spend majority of our time inside. And so that means we're exposing ourselves to specific types of air pollutants, maybe more frequently than we would outdoor air pollutants. And because indoors we may be in a closed area that has poor ventilation, that's only going to further our frequency at which we expose ourselves to these indoor air pollutants. One very common indoor air pollutant is carbon monoxide, or CO. It's classified as an asphyxiant and oftentimes comes from heating units. Some other indoor air pollutants are things such as asbestos, dust, and smoke, which are forms of particulates. We can also see that those indoor air pollutants, especially from our scavenger hunt today, can come from natural sources, human sources, and even combustion. But indoor air pollution tends to look slightly different in developing versus developed countries. Remember, thinking back to Unit 6, we said that developing nations rely more heavily on subsistence fuels, such as woods, manure, charcoal, because it's easily obtainable. And remember, those are classified under biomass fuel types. So when we combust those fuel types, that carbon trapped within that biomass is going to react with oxygen gas, creating things such as CO, some particulate matters, sometimes even nitrogen oxides, and VOCs. When these are combusted indoors, it's usually with poor ventilation, which leads to higher concentration. And when people tend to cook using subsistence fuels, it can result in many deaths. But what does it look like in developed nations? Well, because in a developed nation, we use far more commercial-like fuels like oil, coal, and natural gas, it's usually burned in a closed, kind of well-ventilated furnace or stove. And other indoor air pollutants in developed nations can come from things such as adhesives in furniture, cleaning supplies, insulation, or maybe even paint. Now, specifically looking at asbestos, this is a particulate that we don't really see too often nowadays since it was phased out, but you can find it in older buildings. It was typically found in insulation, but is now known to be linked to lung cancer. It's not necessarily dangerous since we did use it as an insulator, but if that insulation is disturbed in any way, the particulates can enter into the air and eventually your respiratory tract. If you happen to find asbestos in your home or other buildings, professionals are usually called in, requiring the proper respiratory equipment and gear. That area is going to be highly ventilated and usually will be sealed off from other parts of the building to prevent the spread of asbestos. Now, carbon monoxide, a very common indoor air pollutant, comes from incomplete combustion of really any type of fuel. Remember we said carbon monoxide is an asphyxiant, meaning it's going to cause suffocation. And the reason why it does that is because in our red blood cells, we have a protein called hemoglobin. And that protein has what's called an affinity or an attraction to oxygen, or O2. But when we are exposed to high levels of carbon monoxide and we tend to inhale that CO, what happens is that CO binds to hemoglobin and it displaces oxygen gas, causing suffocation. Now, we know it's very lethal in high concentrations in especially poor ventilated areas. It is odorless, colorless, and incredibly hard to detect. So you most likely have a carbon monoxide detector in your home somewhere, similar to a smoke detector. Typically in developed nations, we see carbon monoxide poisoning when we have a malfunction of a natural gas ventilation system. And in developing nations, we can see that in indoor biomass combustion. And actually, we kind of saw that really frequently in what happened with Texas. There was a lot of carbon monoxide poisoning cases due to people trying to have fire pits and light fires in their home with their fireplace to try to stay warm. Now, what about volatile organic compounds? These are going to be chemicals that are used in a variety of ways that usually easily vaporize into the air. They can irritate your eyes, lungs, and so on. We tend to find them in adhesives or sealants used to glue down carpets. That's usually kind of when you have that new carpet smell. That's specifically formaldehyde. We can see it in certain types of cleaners, air fresheners, deodorizers, such as Febreze. We can even see the release of VOCs in plastic or fabrics as well. What about radon gas? Well, radon gas is an actually radioactive gas that comes from the decay of uranium that is naturally found in the bedrock, specifically in granite. Usually it can enter the home through cracks in the foundation of the home and then disperses up from the basement all the way up through the home. It also has the potential to seep into your groundwater, and so not only could you be breathing in radon gas, but you could be exposed to it by your drinking water. It's actually the second leading cause of lung cancer after smoking, and the EPA recommends testing your home with airborne radon monitors. You can also, if you do happen to find high levels of radon gas in your home, you can seal the cracks in the foundation, prevent it from entering. You can increase the ventilation in your home and disperse it if it is detected. Now, what about dust and mold? Well, those are more like natural indoor air pollutants, but they do have health effects, right? They can worsen symptoms of asthma and bronchitis, as well as emphysema. We know that dust is going to settle in homes naturally, and it's usually disturbed by movement or entering air, and eventually enters into your respiratory tract. We can also see mold. It likes to develop in very dark, damp, not very well ventilated places, such as maybe your shower or sink, or maybe even behind a panel in the wall or ceiling. But when it gets dangerous is when it potentially forms what's called black mold. That's actually a class of mold that will release spores into the air, and it's very harmful to your respiratory system, and oftentimes has to be physically removed by cleaning out the mold, fixing the leak, or creating a better ventilation system. Now, what about lead? Now, lead is not as much of a problem as it once was, since it was banned by the EPA back in 1978. But in much older homes, in much older buildings, in where maybe they haven't had a good, refreshing of paint, you can find that the paint is going to chip off the wall or the window pane. Unfortunately, very young children tend to actually either inhale or maybe even ingest parts of this lead, and that can damage the central nervous systems of those children and lead to developing issues. You can also find lead in water pipes, right? They can be released into the drinking water sources. Flint, Michigan is, perfect example of that happening. Now, how do you remove it? You can either strip the paint from your home and replace it with a non-lead based paint. You can also replace your lead water pipes with then copper pipes. All right, guys, so this is the last slide of the day here. Here's our practice FRQ. You have to discuss at least one reason children under the age of 5 are at a greater risk than adults for illnesses linked to household air pollutants. In more developed countries, indoor air pollution is also a problem. Common indoor air pollutants in developed countries include. So at this point, guys, please take a second and pause the video and answer your practice FRQ. Okay, at this point, you should have answered your FRQ. So let's take a look at the College Board accepted answers here. So remember, you had to discuss at least one reason why children under the age of 5 would be at a greater risk for illness than adults. So here were some of the accepted answers here. Right, children we know have underdeveloped or maybe less developed immune systems, which can overall lead to a greater risk of illness following the exposure to any of these pollutants. Children tend to have a lower body mass, leading to a higher relative dose of air pollution. Children spend more time indoors, maybe leading to a higher exposure. Children also have smaller respiratory systems, so mild children have a smaller respiratory system, so mild inflammation may cause far more severe respiratory distress versus than in an adult. All right, guys, that's it for our video. Make sure as you watched, you took notes, and please mark this assignment done in classroom.